Pendidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly.
Teacher Camila, you forgot to unmute your mic.
Yeah.
Okay, sorry. Okay, so good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuition Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting a prayer for Muslims. The non-Muslims may pray according to your own religions. So let me introduce myself. I'm teacher Vivi Lau from SMK Tinggi Klang, the moderator of the day. We at Pusat Tuition Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So are you ready? Let me introduce our teachers for today's lesson. We have Cikgu Shannon from College Matriculasi Pulau Pinang. We are now live on Cikgu Shannon channel. Please support his channel by clicking subscribe now. The topic of today's lesson is phase diagram, and together with us, we also have teacher Kong from College Matriculasi Perak, who is a control host. She's in charge of the smoothness of our lesson and technical support. And teacher Tang from College Matriculasi Selangor. She's an observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat session wisely. Then regarding the certificate link, the link will be given at the end of our session. You can use MOE or Lerima account when you fill in your particulars. And make sure to listen to the passcode given by me during the lesson and fill in the form within the time limit, which is 30 minutes. Without further ado, first let me share the first two passcodes with you. So the first two passcode is A1. Okay. So without further ado, let's begin our lesson with Cikgu Shannon.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. So before we begin our class, okay, let's enjoy this video.
Cikgu Shannon.
Teacher Tang. Teacher Kong. Siku Mawa. Teacher Vivi Lau. Teacher Sazra.
Okay, student, that's intro of pre-U chemistry, right? And this is my, as usual, this is my poster. And okay, and this is my profile. My name is Machan Benawi from College Matriculasi Pulau Pinang. Teaching experience about 21 years, and my channel is www.nurul www.youtube.com/Shahnun channel. Okay. Our topic today is phase equilibrium, and our objective define phase and component, and then sketch and interpret the phase diagram of one component system, and we will focus on water and carbon dioxide and explain the anomalous behavior of water. Predict how phases may change with changes in temperature and pressure. We call it isobaric and isothermal. First, we look at the definition of phase. Definition of phase: homogeneous part of a heterogeneous system that is separated from other parts by a distinguishable boundary. Okay, this is a definition of phase. And then this is a definition of component: a distinct chemical species in the mixture. If there are no reaction taking place, the number of components is the number of separate chemical species. And this is example of phase and component. For example, we have mixture of ethanol and water. Because ethanol miscible in water, so we will have only one phase, because we cannot see the boundary between water and ethanol. All right. What about component? We have two components. Okay, component of ethanol and component of water. And then the second example is mixture of oil and water. We know that oil immiscible in water. Because of that, we will have two phases of liquid, because we can see clearly the boundary between oil and water. Okay, so we have two phases of liquid, two different type of liquid. And then the component, of course, we have two component. Component of water and component of oil. Okay, the second example is pewter. Okay, pewter, an alloy of lead and tin. An alloy of lead and tin. In this case, only one phase of solid, because we cannot see the boundary between lead and tin. They blend together. We cannot see clearly from our naked eye. Okay, only one phase of solid, and the components still two. Okay, we have a component of lead and component of tin. And this is a last example for phase and component: mixture of iron powder, copper strip, and water in a closed system at room temperature. In this case, we have how many phases? Okay, because iron powder and copper strip, we can distinguish them. Okay, powder and strip of copper, we can differentiate. That means we have two, plus water. Okay, plus water. And then water in a closed system, we know that the water will evaporate, become a gas or vapor. So we have four phases in this case. Okay, two phases of solid, iron powder and copper strip, one phase of liquid, there is water, and one phase of vapor of water. So four phases. And for the component, we have component of iron, component of copper, and component of water. So three components. Yeah. All right. Okay. After that, we go to the phase diagram of water. Okay. In meteorology syllabus, student should know how to sketch the phase diagram of water correctly. Okay. First, y-axis is pressure. Okay. For example, ATM, torque, or Newton per meter squared, and so on. And x-axis is temperature. It could be degrees Celsius, it could be Kelvin, no problem. And then the curve is like this. Okay, we have the curve like this. Like, can I use this? Okay, okay. Can you see the arrow here? Okay. And then we have to label. We have a curve A to T. Okay, A to T, and then curve TB and TC curve. So we have three curve: AT, TB, or TC. Or you can change A to whatever you want. If you don't like A, maybe you can change with X, for example. That one's no problem. And then after we have this curve, we have to label which region is solid, which region is liquid and vapor. Okay, and to actually, if we look at this sketch, like glass, right? This is like a glass. TB, TC, and TA, it looks like glass. And inside the glass, we have a liquid. So here we have a liquid here. So this is the easy way how to remember which part is liquid and so on. Okay, this is like a glass. Inside the glass, we know that we always put inside here is a liquid, and the vapor at our right hand side, and solid at our left hand side. Okay, we have to write the liquid, solid, and vapor, and then the T point here, T here, actually is a triple point. Okay, T is triple point, and what is the triple point? The temperature and pressure at which the gas, liquid, and solid phases of a substance are in equilibrium. Okay, that's why they call it as a triple point. Triple, gas, liquid, and solid. Okay, are in equilibrium. Okay, that is number one. The point that you have to label when we sketch phase diagram of water. And for water, the temperature at triple point is 0.01, a little bit higher than 0 degrees Celsius. Okay, 0.01. And then the pressure is 0.006 atm. 0.006 atm. Okay. All right. What is AT curve? Okay. AT curve, curve AT, is the sublimation curve. Okay, we call it sublimation curve. At the temperature and pressure, the solid and gas phases are in equilibrium. Okay, along this curve from A to T, T to A, actually the solid and gas are in equilibrium. Okay, we call it sublimation curve. And then we have TB, curve TB. We call it the fusion curve or melting temperature line. Okay, freezing curve. So many names. And for water, the fusion curve or melting temperature line or melting curve or freezing curve tilt to the left. Okay, slope to the left, tilt to the left. And then equilibrium is established between the solid and liquid, because here is solid, here is liquid. So along this curve, even though it looks like a line, but we still call it curve. Okay, we still call it as a curve, the fusion curve. Along this curve, the solid and liquid are in equilibrium. And all right, if we make a horizontal line, and the line is intersect with one ATM here. One ATM, pressure ATM. The pressure, the temperature here. The temperature here is actually what we call a normal freezing point, 0 degrees Celsius. Okay, 0 degrees Celsius. There is a normal freezing point or normal melting point. Okay, the same thing. Normal freezing point or normal melting point are the same. All right. And then we have curve TC. Name for the curve TC is the vapor pressure curve or steam line. Okay, the liquid and gas are in equilibrium. Okay, along that curve TC, the liquid and gas are in equilibrium. And the same thing, now we are missing off the curve. Maybe I have to, where is, okay. Maybe I have to write the curve here. All right, this is the curve. Okay, this is the curve. The curve is missing. In action, okay. The curve of TC, we call it the vapor pressure curve, and along that curve, liquid and vapor are in equilibrium. And if we draw the horizontal line that intersect one ATM to the TC curve, and the temperature there, we call it what happened to my PowerPoint? Okay. Where it? Okay. My PowerPoint. Okay, we call it normal boiling point. Okay, we call it normal boiling point. And the temperature of normal boiling point of water, we already know that 100 degrees Celsius. Okay, and then, all right, the line is there already, so I can delete this. Okay. Okay. The last one is critical point. Point C on top of TC curve. Okay, on top of TC curve, we call it critical point, and the point of critical point temperature is 374 degrees Celsius, and the pressure is 218 atm. And at this point, liquid and gas become indistinguishable. Okay, liquid and gas become indistinguishable. Once the critical point is reached, there are no distinguishable two separate phases because the density of gas and liquid are equal. Okay, so we call it critical point. Below this critical point, we still can see the change from liquid to vapor. Okay, liquid and vapor. But above this critical point, we cannot distinguish the vapor and the liquid of water. Okay, because of that, scientists call it as a critical point. Okay. What time now? Okay, we still got a lot of time. Huh? Okay, anomalous behavior of water. The phase diagram for water actually is not typical. Not typical. The melting temperature line, as we can see, the TB slope, slope to the left. Okay, the TB curve slope to the left. That means the melting temperature decreases with pressure. And because of why water behave like this? This is because the water is denser than ice. Okay, water is denser than ice. That's why the TB curve slope to the left. Okay, slope to the left. But other than water, for example, carbon dioxide, oxygen, and whatever component, except for water, we will find that the TB curve will slope to the right. Okay, that's why we call that the anomalous behavior of water. The water has this kind of anomalous behavior because the TB curve slope to the left. Okay. Okay. This is a 3D structure of ice. Okay. Why water, the ice or the solid phase of water has less density compared to its liquid, because when it's become a solid, as we can see here, it will have a 3D structure that a lot of we can see a lot of space here. Okay, this is a hydrogen bond of water molecule. Each water molecule will have a hydrogen bond. Okay, each water molecule will have intermolecular forces of hydrogen bond, and then it will become like this, the 3D structure of ice. The structure has an open structure, and because of that, the density of solid water less than density of liquid water. Okay, because the mass is the same, but the volume of ice bigger than the volume of water. Okay, we can see the open structure here. So because of that, the water is a unique substance. The solid of water less dense than its liquid water. All right. Because of that, ice is less dense water, and as we can see here, fishermen here has to make a hole, and because here is a solid, we can walk on the top of the lake, but inside here we have a liquid water, and we still have a living creature here, there, and of course here we have a fish. Okay. All right. This is question number 1. What time now? 20. Okay, 20. Okay. This is question of liquid phase diagram of water. What phase changes will take place when water is subjected to varying pressure at a constant temperature? Okay, constant temperature of 0.005 degrees Celsius. 0.005 degrees Celsius. That is question number 1. And question number 2 at 40 degrees Celsius. And question number 3, negative 40 degrees Celsius. Okay, we want to know the phase changes at 3 different temperature. Okay, we constant the temperature and we varying the pressure. We call it iso. This one is isothermal, because constant temperature. Okay. Let me show you. Wait, where is okay? I have a all right. First, wow. Oh, I cannot. Okay. First, at 0.005. 0.05 means this is a triple point, 0.001. So it could be here. It could be here. This one could be 0.005. Okay, 0.05. So somewhere here. Okay, let me see somewhere here. And then we make a line that we call it constant temperature. Constant temperature, but we varying the pressure. Okay, no, we will have a line like this. All right, until here. Okay, until here. So, how many points that we can get from here? 1, 2, 3, 4, and 5. Okay, I have 5 points. 5 points of the phase of water. Number one is the phase of water is a vapor. Okay, point here. Maybe I can put it as 1. Okay, let's say 1. This one is 2. This one is 3. This one is 4. This one is 5. At point number 1, the phase of water is vapor or gas. Vapor, right? And then it's become, go to the point number 2. Point number 2, solid and vapor in equilibrium. So vapor, POUR. Maybe we can use this kind of sign. And solid. Okay. And then at point 3, so here is point 3, it's become solid. At point 4 is become solid and liquid. Solid and liquid at equilibrium. And the last point number 4 is a liquid. All right. This is phase changes take place at constant temperature 0.005 degrees Celsius when we varying the pressure. All right. And then look at 40 degrees Celsius. 40. So this one is degrees Celsius. 40 maybe here. Somewhere here. Okay, somewhere here. And varying the pressure. Okay, how many phases? Only? Anyone there? Anyone in the chat box? Anyone? Anyone can write something on the chat box? How many phases? How many phases? Teacher Kong? Anyone?
So far, nobody write it.
No. How many phases here? 1 here, 2 here, and 3. 3. We have 3 phases at 40 degrees Celsius. 40 degrees Celsius. Begin from vapor, and then vapor and liquid in equilibrium, and then liquid. All right. And for negative 40, so maybe here we can take any point that below negative 40, maybe here, and when we varying the pressure, also 3 phases. Okay, from vapor, and then vapor and solid, vapor and solid in equilibrium, and then it's become solid even until here. Okay, above 218 solid. Okay, it cannot reach the liquid phase. And for 40 degree, only vapor and liquid. All right. Okay, I have to.
Cikgu Shannon, can we rest for advertisement?
Okay, good.
Okay. Before we rest, I give you the next passcodes for today. 2. Okay, so we have 2 and 2. 2. Okay.
Okay, good.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Akademi YouTuber.
Okay, Cikgu Shana, you can continue.
Okay, welcome back. Okay, let me. Okay, now we look at the phase diagram of carbon dioxide. Okay, first we can see the curve, the different type of curve. As we can see, the curve of TB. Okay, the TB curve. Okay, all right. And then we have to write which part is solid, liquid, and vapor. And the curve is still like a glass, right? Like a glass. And here we have a liquid inside the glass, and here we have a solid and vapor. Okay. And the T is triple point as usual. We have a triple point, and then we have a AT curve, and then TB curve, and the TC curve. And the name for the curve as same as water, right? We have freezing curve, sublimation curve, and so on. Okay. What happened? Okay, no problem. I can draw here. You know, I will draw something here. From here, we have here, and then, okay. All right. Okay. The pressure of triple point for carbon dioxide is 5.2. Okay, 5.2. If you look at the pressure of carbon dioxide, more than 1 atm. More than 1 atm. This is very important. We can see the phase changes in carbon dioxide because of the pressure, the triple point, the pressure of triple point of carbon dioxide. And then, oops, I have to change this one verse. Okay. All right. All right. And the temperature of triple point of carbon dioxide is 216.4 Kelvin. Okay, doesn't matter whether it is Kelvin or degrees Celsius. That doesn't matter. Okay, 2.14.4 Kelvin. And the critical point for carbon dioxide is 73 atm, and the temperature is 204 Kelvin. All right. The melting temperature line slope to the right. This is the difference of carbon dioxide with water phase diagram. Okay, the TB curve. We call it melting temperature line. Okay, melting temperature line, or sometimes freezing slope. Okay, in carbon dioxide, we can see that the melting temperature slope to the right, tilt to the right, slanting to the right. Okay. For water, tilt to the left, or we call it positive slope. Okay, we call it positive slope. Water, negative slope. Okay, why? Because solid carbon dioxide is denser than liquid carbon dioxide. Okay, if we have this kind of question, this is the answer. Okay, why? The melting temperature of carbon dioxide slope to the right? The answer is solid carbon dioxide is denser than liquid carbon dioxide. If the question is why the melting temperature of water slope to the left, the answer is solid H2O is less dense than its liquid water. Okay. And then, okay, I have to, okay. At constant pressure, as T increases, this is my PowerPoint. Okay. We have a point of X. Okay. We have a point of X and point of Y. Okay. We call it at constant pressure because we don't change the pressure. In this case, the pressure is 1 atm here. Okay. This is 1 atm here. If we change the temperature from X to Y, okay, from X to Y, carbon dioxide exists as solid. Okay, we know that at this region, okay, and point X, in this region is solid, and at point X, carbon dioxide is in solid phase. Okay, to Y, Y is still solid. And then until it reaches the point Y, the solid and gas are in equilibrium. Okay, and then we continue. Increase the temperature of carbon dioxide until point Z. Okay, after Y, only carbon dioxide gas until point Z. And then, what is this? Okay. Okay. The triple point of carbon dioxide, as I mentioned before, 5.2 above normal pressure because our normal pressure is 1 atm. Okay, the triple point is above atmospheric pressure. Thus, at atmospheric pressure, carbon dioxide sublime. Okay, from point P, Q, R, as we can see that from solid, when we increase the temperature, at normal pressure. Okay, our atmospheric pressure, solid carbon dioxide will sublime. Okay, we change directly from solid to gas. Okay. Okay. All right. Okay. Now we have at constant temperature. At constant temperature, we call it isobaric. Okay, isobaric. Constant. Oh, this one is constant temperature, isothermal. Before this, isobaric. SP increases from Z to Q. From Z to Q, carbon dioxide exists as a solid gas. Okay, point Z, the phase of carbon dioxide is gas, and then until point Q, it's become gas and solid in equilibrium. And then after Q, it's become V. Okay, in between Q and V, the phase of carbon dioxide is liquid. Okay, in between Q and V, Q and V. Or here it's Q before V. After Q before V, okay, Q before V. Between Q and V, same thing lah. Only carbon dioxide liquid exists. And then at point V, the liquid and solid are in equilibrium. After point V, let's say we take point W. Now it's become solid, right? It's become solid. This is what we call isothermal, because we do not change the temperature of carbon dioxide. We varying the pressure. Okay. Question 2. This is question 2. Dry ice. Dry ice actually is a solid carbon dioxide. Okay. Dry ice. Okay. Solid carbon dioxide does not melt at atmospheric pressure. It sublimes at a temperature of -78 degrees Celsius. This is the question. What is the lowest pressure at which carbon dioxide solid will melt to give carbon dioxide liquid? This is the question. Okay, I want to highlight the question. Where is my... All right, here. Okay. Where is my pen? Okay. Okay. Lowest pressure, okay, will melt. Okay. Okay. Lowest pressure. First, melts mean from solid to liquid, right? Solid to liquid. So it should be the lowest pressure should be above a little bit more than 5.2. So maybe here, maybe here, maybe here, maybe here, maybe here. Lowest pressure at which carbon dioxide will melt. So, and then we increase the temperature, then carbon dioxide solid will melt. Below 5.2 atm, solid carbon dioxide do not melt. It will sublime from solid, directly change the phase, become gas, right? So the question is, what is... Oh no, the temperature is -78. -78 should be maybe here, -78. -78 plus 273. Okay. 278. Okay. 351. Okay, here. Okay, so maybe here. Maybe here. Okay. Maybe here. Okay. Okay, maybe here, from here. So the answer is, what is the lowest pressure? Above. Okay, the answer is above 5.2 atm. Okay, probably temperature will just okay. Above 5.2. Above 5.2 minimum lah. Lowest pressure 5.3 lah. Okay, 5.3 atm. Okay. Your answer should be 5.3, 5.4, 5.5, and so on. And then we increase the temperature, and we can see that the solid carbon dioxide will melt. Okay. All right. Any question from student?
So far, no yet. So far,
No,
no.
yeah. All of them understand very well. Okay. Phase diagram. Let me. My PowerPoint. Okay. Okay. Summary. Okay. I have to. Okay, this is the last part. Last part. Summary for this subtopic. Okay. Subtopic. What is phase? Phase actually is a number of layers. Okay. Very easy for us to remember. What is phase? Number of layers. Because we have the phase actually it can be in liquid, for example. We have two different type of phases of liquid. For example, in oil and water, right? Even though in gas also, maybe we have a gas that has a color, for example, okay? We can see the different in color, so we can see the boundary. Actually, phase is number of layer. And component, what is component? Number of chemical species. If we have a carbon dioxide, we know that carbon dioxide is one of a species of gas. So carbon dioxide, we have oxygen, for example, carbon dioxide and oxygen, different kind of component. Even though we cannot distinguish in using our naked eyes, but we still know that carbon dioxide and oxygen are different component. Okay, but we cannot see the boundary. The phase is one, phase of gas. Okay, and then you have to know how to sketch the phase diagram of water. Okay, the phase of water just like this. Okay, the phase diagram of carbon dioxide and phase diagram of carbon dioxide, phase diagram of oxygen, phase diagram of nitrogen, all are the same. Okay, all are the same, but different in triple point, critical point, and so on. Okay, but they have same what we call it, same of shape. Okay, shape, the curve, the curve inside there are the same for all component except for water. Okay, only water, the melting curve or freezing curve slope to the left, or we call it negative slope. Only water. Okay, so if you know this, and if the question is like the X component, and then the sketch is the melting curve slope to the right, we know this is not water. It could be carbon dioxide, it could be nitrogen, it could be anything else, except for water. And then the last one is changes in phase when pressure or temperature is changed. Okay, if we varying the pressure, and then we the pressure varying and the temperature we constant, we call it isothermal. Okay, constant temperature, we call it isothermal. Constant the pressure, we call it isobaric. Okay, isobaric. And you have to know the phase changes. The phase changing in this component, whether water or carbon dioxide and so on. When we change the temperature, what happened? Whether it's from solid to liquid to gas, and at the boundary of solid and liquid, we call it for boundary of liquid and solid, we call it liquid and solid in equilibrium. Okay, if you know all this, I think no problem about phase diagram. Okay, phase diagram. I think that's all for today. Thank you. Only 48 minutes. Okay. Thank you very much. And go back to teacher Vivi Lau.
On my mic. Okay, sorry. So I will give you the last two passcodes, 9 and 8. Okay, so thank you, Shannon. Thank you, Teacher Shannon. So with God's grace, we are done with today's session. We have learned a lot from Cikgu Shannon about phase diagrams. Congratulations to those who are able to follow our session from the beginning till the end. And thank you very much to Cikgu Shannon for such an interesting lesson. Before I provide the certificate link, please check the checkbox for the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Cikgu Shannon for giving you a free lesson today. Don't forget to click the bell button too, so you won't miss out any new videos and live classes from Cikgu Shannon. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? Once again, I would like to thank you, Cikgu Shannon, for the interesting lesson. Thank you also to Teacher Kong and Teacher Tang for being with us today. I think that's all for now. See you in another session. Please do remember to stay tuned. Goodbye, everyone. Have a nice weekend.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit Ayu untuk dikumpul. Jom ikuti kelas tuition live Ayu untuk mengumpul kredit Ayu dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutube.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTube.